Hello, this is Tyson Frederick, and this is my CS2316 project, and my topic is California COVID spread analysis. So first and foremost, I know this topic was recommended against. So initially I tried to go a couple other separate routes, tried to look at, crop yields and stuff like that, because that stuff interested me as well. Couldn't find a lot of data on it, and I had personal ties to the state of California and the spread and kind of the effects in California of the pandemic, and it kind of hit close to home for me, so I thought it was only fitting to go back to that and find some useful insights. Some other points of interest for that obviously was a major pandemic, and I'm super interested in the healthcare industry. I could see myself working there in the future, so I thought it would be an interesting project to do. My hypothesis was that the effects of COVID-19 would be much more detrimental to LA County than the rest of California due to high population density, and that the spread of the virus would mirror other common viral infections like the flu. So the purpose was to understand how the virus spread and what measures could have prevented it, and to find out how the virus differed in dense cities compared to larger land areas like the rest of California. So for my data sets, I had a CSV file called LA County COVID cases that is currently being updated. It's very up to date on everything, and I used that for the bulk of my information. I had a web source, an HTML file that I scraped through. That was a Wikipedia page that had the list of counties in California. And then I used the United States Census Bureau API to get some information about California state as well. So for my data cleaning, I began with just over 50,000 rows and 15 columns in my CSV file, where each row was a different day where a case was being reported, whether it was a new death or a new case or what have you. And the columns had, the new case, number of new cases in that day, the number of new deaths, the time it was reported, the day it was reported, where it was reported, latitude, longitude, a whole bunch of that information as well. So for this download data set, my CSV file, I started by changing all the rows with negative cases to 0. This was a super weird inconsistency, and I'm not sure why it was like that. But some of the new cases were negative numbers, which didn't make sense. Changed them to 0 because of that. I changed some formatting with the date and time, converted some of my blank cells to NA so they didn't affect with my data collection. And I dropped all of the rows that had 0 new cases or new deaths throughout the entire day because I didn't need them for anything else. And I got down to 46,000 rows, give or take. So that was a little bit less than I started with. And then for my web collection source, I used a GET request in Beautiful Soup to scrape that Wikipedia page I talked about. And to go inside the desired table on that page, I deleted some unnecessary columns I didn't want and made a list of lists that was in CSV format. So then once I edited it and made all the changes I wanted to do, I just export it as a CSV file. And it looked something like this. It was 59 rows and 9 columns, just had information about each of California's counties, especially LA County, which I wanted to focus on. So for my API, this was a super clean data set. Funny enough, you could actually, in the URL, you could decide what you wanted to get from it. So I wanted the name and the population and everything else that I wanted to, you put straight into the URL, so you didn't have to narrow it down when you called the API in your Python code. So this was different from what I'm used to. It was a little bit different of an API, but still seemed to work out the same. Ended up giving me a list of lists instead of a dictionary, which I thought could be a problem, but cleared it up in phase 1, and it seemed to be just fine. So this is kind of what it looked like. It made it a little bit harder to sort because it was not a dictionary, but we got through it anyway. My first insight I wanted to talk about was the spread of the virus by month for the state of California. This was by far my most tedious insight. I had to go make a variable. I didn't have to do this, but this was the simplest way initially of what I thought of to do it, and afterwards this was very inefficient to write, but that's how it ended up being. I learned the eval Python built-in method. It kind of helped me convert strings to lists. Not a super secure method to use, but it worked well for this project for sure. And this created a list of tuples, and through this I found that the number of new cases in California in January over 91 million, but in May just over 100,000. So this was just a huge disparity in the number of cases depending on the time of year, and this kind of dipped my toes into the water for some of the findings that I would get to a little bit later. So I had along with this a visual and exact information that I had before, but you could kind of see it a little bit better. It looks like I don't have any data for April to November. This isn't true. All of these months have 100,000 to 500,000 new cases. But when you have months like December and January that have 80 to 90 million new cases, that it trumps those other values, and you don't even hardly see a bar on it. So my second insight, I wanted to normalize my values. I wanted to find a way to compare the state and county level. So I had to use my other sources, my API and my web scrape, to normalize my values, which you can see I did in the code here. Obviously using my beautiful soup and everything. So I just wanted to be able to compare the number of cases from the population of each. And by doing this, I created a dictionary. So each of these is a dictionary for LA County and the state of California respectively. And it's the number of new cases that they had divided by the population for each month of the year, which I made a visual for an extension of, and I made a line graph on this one, and I think it worked really well and showed me that Los Angeles, compared to their population, had a much faster rate of spread than the rest of the state of California, which again, back to my hypothesis, was something I expected to happen. So this was good to see. My third insight, I wanted to look at the spread of the virus across each of the 4 seasons. This was by far one of my simpler insights, but again, it was part of my hypothesis and my purposes. I wanted to see how it stacked up to other viral infections. So I wanted to look at this as well. And I found that 68 million cases were reported in the winter, while only 220,000 were in the fall. I expected that difference to maybe be between winter and summer instead of winter and fall. I thought fall it would start picking up, and then come winter it would be in full force. It was not the case at all. Fall had by far the lowest numbers, which was interesting to me. Still pretty closely following the flu, but not exactly. I would see the flu more being starting in the fall, ramping up in the winter, but this was starting in the winter and then ramping up in the winter and going to spring. And I had a visual that represented that as well, my pie chart, where you can see that over 99% of new cases were in winter and spring throughout the entire year. So for my fourth insight, this was just kind of something that I thought was intriguing and interesting to look at. I wanted to find the maximum and minimum new cases compared to the day of the month. So you can see my code here. I sorted through and I sorted through my clean file and sorted it by the number of new cases, where I went in and found each day. And I found that the absolute minimum was 372,000 new cases on the 11th of the month, and the 23rd of the month had over 22 million. Huge difference. I found that there definitely is some correlation between the day of the month and the number of new cases, and I thought that it would be biased against days at the end of the month, since not all months have the same amount. But as you can see here, the 30th of the month was second highest, which was completely against what I thought we would see here. So that was super interesting to see. And my fifth insight, I wanted to find the proportion of lethal cases in LA County versus California State. So I sorted through that CSV file again, summed the number of new cases, summed the number of deaths, and divided the deaths by the new cases to find the proportion of cases that were lethal. As you can see, I made a dictionary for each month. Right here you can see, and then I subtracted California from LA. You can see I got negative 4.6%, and that meant that cases in LA County were 5% more lethal on average than in California State, and months with fewer cases tended to have higher severity. So kind of recapping everything, my overall results, areas like LA County with higher population density tended to have more severe outbreaks and faster spreading. And then the way COVID spread and trends throughout the year almost perfectly matched other viral infections, apart from maybe that fall to winter turnover compared to in COVID, we had kind of the winter to spring. And then finally, when COVID spread lessened, like in months, you can see here, in months like April when we had hardly any cases, about 5% of cases turned lethal. So as the virus stopped spreading as much, it just began to strengthen. So this was super interesting to find. Thank you.